So I work with a company called matrix.org, and my job title there is Guardian of the Matrix. And this is so cool. I'm one of several guardians, and it's a very interesting company. So, and this is to illustrate some things I'm going to talk about. So Matrix.org was a relatively new company started by a bunch of undergraduates from my university in Cambridge a few years back. And actually, they came to me in a pub. Sorry, I should remember to drink this. We're in a pub. And they had the, cheers, yes, and they had this idea, and I said it's a rubbish idea. And I was completely wrong. They have literally millions of customers, including bits of the French and German government now. What they did is they built a decentralized platform for secure messaging. That's the kind of starting point. And it links all the other messaging systems. So imagine you're working with a bunch of people in several organizations, could be government, could be businesses, whatever, and they all have already started using some systems. These people over here might use WhatsApp, and these folks over here might use Slack, and these people might use something else. And so you could all just adopt one of them. It's kind of annoying, it takes too long, or you could just glue them all together. And these guys were like, we're going to glue them together. But you glue them all together, you better do better security, you do better than the best of all of them. And you better do, one of these things is to do it in a decentralized way. So rather than having some big cloud-based service, which is kind of what I'm going to be mainly concentrating on, that where all your messages go to, and if one thing goes wrong, everything about everyone is potentially revealed, you reduce that risk. It doesn't eliminate the risk completely, because obviously the software could all go, it could have a vulnerability that's discovered. People could find backdoors in software. Actually, I should just kick off because I'm not calibrated on the audience. Put your hands up if you write software. Right, okay. I guess you kind of look like people like that. Put your hands up if you have anything to do with regulation or law of software, or other, or policy, or buy systems for people, or, okay, interesting. Oh, right, okay, thanks. All right, so that wasn't everyone, it was about half of people, so I still have to stay away from too many deep dives, and I don't have time to do deep dives into details about software problems. But the matrix.org thing, yeah, so it's an interesting thing. So one of the other things about it, the reason we have this silly job title for people, is the governance model, which is a very important thing in the modern world, of the companies. There are two companies. There's essentially a community interest not-for-profit company, and there's a for-profit company. These people are not mad. They want to make money, not a stupid thing to do, but they want to be kept honest so that they don't drift away from their mission, which is to do this system. Now, I bet everyone here has at some point used Skype. And you know that Skype was originally written by crazy hackers who had a completely peer-to-peer approach to the world, decentralized. Very, very well-written piece of software. In fact, there are at least two things in that software that are strokes of genius. It's decentralized, and it had very, very good audio and video codecs. So the audio and video actually worked really well. It also, which the user shouldn't care about, but when it goes wrong, you care, had very good security. And their business model was pretty cool, because it was you give them some money and they do call out on local phone calls, and that gets everyone in the world running arbitrage on the entire world telephone network, which is a good way to make a lot of customers happy, right? The Skype got acquired by eBay, which then got fed up with, they couldn't figure out how to integrate it with auctions, so the software got bought by Microsoft, and Microsoft centralized it all. And anyone like to claim it's as good? Because I don't believe so. So decentralization is one thing I want to talk about, but it's not the only thing. And the whole point about cloud computing is it is a thing for good. So cloud is, this thing that's emerged that I believe the first person to use the phrase cloud computing was a guy called Simon Crosby from Cambridge. And we had written this software for virtualizing computers so they could be shared between lots of people. And people may be familiar with the Zen hypervisor. It's a long time ago, more than 15 years ago. And they were trying to sell this idea to American companies that had data centers, lots of computers in a big warehouse, that you could share those compute resources, storage and processing, with lots of customers, but you need to isolate them from each other. And the idea of doing this was that you want to hide the fact you're sharing this resource from this set of people, from this set of people. The isolation should be out of your mind. You should not have to worry about it. And so you sort of draw a cloud. You say, you've got these compute resources in this cloud, and you've got this one in this cloud, and they're different, and you don't see each other, right? That's kind of the notion. This, in fact, comes from much early pictures of the internet. I'm not joking, from the late 70s. When people were connecting stuff to the network, they'd connect a line from I don't know, Goonhilly to London. Goonhilly is down Cornwall, a satellite link, and there'd be another line from London to Rutherford Labs. There'd be another line to Oslo, I'm not joking. And then where did it go next? They go, oh, you don't have to care about it. We'll draw a cloud. They just draw a picture cloud. And in there, we don't care. So it's a sort of way of abstracting away the details. Okay, move much later, and the cloud takes off as a way of building compute services. And it's a way of amortizing your costs, of aggregating the computing demands of lots of people in one place, and then having a bunch of people who look after the resources who've got skills, and you put them in one place. You don't have to distribute them everywhere. You pay them quite well, crazy amounts of money actually, but then, you know, they look after, and I'm not joking here, you know, a company like Facebook or Google or Amazon or whatever, or Microsoft or Tencent in China, whatever, will have cloud data center, single data center with 1 million cores. That's quite common. It's not an exaggerated number anymore. A few years ago, that would be a sort of the very high-end aspirational number. That's quite normal. And some of these companies have 3,000 data centers around the world of sort of that, approaching that scale. And so there's an economy of scale of doing this. And so that economy of scale attracts people to the idea of running their computing and storage in these cloud services. So then you think, okay, well, what could possibly go wrong? Why would this be a bad thing? So I'm going to approach this from a slightly different direction, which is to talk about a couple of things we're doing in the Turing Institute, which don't involve using public cloud computing or the cloud services. We don't go to Amazon or Google or Microsoft Azure cloud service or some other company, but we work with people that have their own data centers. So the two examples I'm going to talk about are the National Health Service and the Financial Conduct Authority. Okay, so in the UK, we are blessed with a fairly good, WHO ranked, 23rd or something, extremely affordable, cheap, basically, health service, which does okay. And it's got fairly good coordinated IT systems nowadays after a lot of pain. It certainly has a good network, and it has picture sharing, it has patient record systems and so on. Some parts have done better than others, so Scotland and Wales have federated all the trusts, and you can do stuff on all the data. Now, what we would do in the Turing Institute is we would not exfiltrate the data. We wouldn't export the data. We wouldn't take the data out of those data centers. It's held there in each of the separate data centers for this GP, little office, for this bigger practice, for this clinic, and for this whole hospital and this set of hospitals in a trust, whatever. And they have a bunch of very good practices, actually probably some of the best security practices around. And you can ask me later about attacks on NHS, but they generally don't do very well. So these people are pretty good at it. So when we rock up and we say we'd like to do some data science and machine learning and AI on your data, and they're like, yes, but we're not going to give you the data. So what would we do? Well, we would throw our programs over the fence into their data center and run them there, and we would work with a medical researcher who is cleared, okayed, ethically signed off, and can be fired and sent to jail, by the way, if they break the rules, but also understands the output. So imagine we're trying to do something relatively simple, and an early thing we did a year and a half ago was looking at NHS Scotland data on hospital readmission. So you've gone into hospital after an accident, or you've gone into hospital after elective surgery. What's the chances for a given day in the next year? What day is the most likely one you're going to go in again? So you take the historical data and you build a predictor on the data. We don't need to look at the data. We show the answers that this program does. We build a very simple AI. It's not rocket science at all. It's a 25-year-old technique. And it's 98% accurate at predicting the day you next go into hospital. That's really useful because you could go to your GP with some symptom and the GP runs it for you because you're their patient. So you've got a trust relationship. They're allowed to look at your data at this point. And they go, ooh, you need to go in now or tomorrow or next Wednesday, right? And what that does is it schedules the health resource much better, and it also reduces all the risks of going in an emergency rather than in a predicted time. So it's a very simple thing. But at no point did we export all the data to a bunch of people who might be risked. They might be coerced, bribed, all kinds of things into leaking the data. Or we might just make mistakes and somebody might walk out with a USB stick with all the data on and leave it on the bus, or print out loads of stuff and leave it on, on a plane or whatever. So that's a sort of example of a way of working which is not public cloud. It's a way of moving programs into a private cloud, a private data center. Actually, it's a bit more complex because you have to access these federated sets of data. Even within the NHS in Scotland, for example, you don't actually pull all the data to one place. You run queries, you ask all these different places and say, we need the hospital admission dates for all these people across all these places. We're going to not need their names and addresses at this point. We're just going to build a thing that does a prediction. And later on, when this is all trained up as a program, it can be handed to GPs. We haven't done that yet, which is the next thing we really have to do, because that would be really useful. And they could then use it in practice, right? And then from then on, you've got something useful. So that's kind of an example of a way of working which doesn't use a public cloud. And in fact, the reason we've been working that way with health, and I'll talk about financial contact in a second, is that if we did make a mistake, you know how bad it is under current data protection law if you make a mistake. And you essentially the ICO, the Information Conservation Office, not Bitcoin offerings, but the office that looks after data protection law, can fine you some large percentage of your annual revenue. You could be in massive trouble, and so it's not a good idea. And best practice would be the benchmark they would use. What would be a good thing to do? Exporting your data from health to the public cloud, similarly financial records, which is highly personal, highly private, sensitive, and also very valuable, would be a foolish thing to do, because the public cloud can't really protect your data, and we'll get onto that in a second. There are ways you might be able to do it in the future, and we're working on that, but it's not a good plan at the moment. So in financial conduct, you could do the same thing. So if you know about financial regulation, everywhere has the regulators, and every now and then things go bad in the world's economy, and so the regulators sharpen their teeth a bit. So Financial Conduct Authority right now has slightly sharper teeth, and it has access to all the transactions in the UK, so every credit card transaction, every bet placed, everything. And there are all kinds of interesting patterns in that. Again, they don't want to look at all your data. What they want to do is look at the patterns and build predictors for when things may be going wrong. These could include, there's some very clever collusion going on between a set of people laundering some money. So you'd like to spot a very subtle pattern. It's quite a hard thing to see. But you don't want to look at everyone because it's creepy, but also it has a chilling effect on innovative behavior, and in the same way that surveillance on society is not a good thing. Bulk surveillance all the time. If you don't believe this, the reason we have really good data protection law has largely come out of Germany, and it recently came out of Germany and the EU, was that their experience under the Stasi in East Germany, because it was so horrible having this 24/7 panopticon surveillance of society, and that once they reunified, they were like, we've got to do something about enforcing that doesn't happen, and you can't just do it by consensus. You better have law to stop governments to go overreach, right? So the third thing we do in the Turing is we work with defense people and security people, and they do surveillance. However, they, under UK law, are under the Investigatory Powers Bill, and that nails them to being good guys too. So, they didn't used to exist. There was no MI5 or whatever, but now they're a thing, and you can go to the National Centre for Cybersecurity and get advice, which is jolly good. And they will, again, they want to find patterns of bad stuff without looking at everything you say, because that's not great. That's not good for society. And then when you find a pattern, then you switch modes. So each of these cases I'm trying to illustrate, there's okay, we spot a healthcare pattern, but how does that work? It works with consent between people. So you go to your GP, and your GP says, we're in hospital, we need to talk about what's happening next, how do you feel today, other things you might want to check, blood pressure, all these other things, and it goes into this program. And this is a consent point. And the Financial Conduct Authority finds a funny pattern. What do? They go and get a warrant. And Investigatory Powers Bill, you go, if it's national security, you still have to go to a judge and you get a warrant, and then you can do the intercept. So this is the kind of separation concern. It doesn't involve privacy in the cloud. All these things involve data that's kept near the people who are working with people in health or finance or whatever, and it's not exfiltrated to magic other people. And I mentioned a thing that's very important here, which is value. The data is highly valuable. The healthcare is probably the easiest case. I mean, the financial is highly valuable. If you're a trader, any traders in the room, you can build models of what's tomorrow's book based on everything that happened today. This is all cool, but healthcare, this is super valuable. So there's a nice example of working between some folks at UCL and statistics who are partner, University College London, a partner in the Turing, work with DeepMind, famous company who does really clever deep learning, with Moorfields Eye Hospital, where I'm actually an inpatient every year for a day when they do weird things with my retina. These folks have the world's leading eye surgeons, and they have huge tens of thousands of records of retina scans. And so you can do some image classification on these retina scans, no invasion of privacy, and you can train an image classifier, just like everyone has in a smartphone, that goes, there's a face, oh, that's my friend Jim, right? So this thing says, there's a feature, oh, that's a predictor for retinal detachment, or more importantly, very common thing in elderly macular degeneration, which could be halted. Across the world, every year, 1 million people go blind from macular degeneration. That's incredibly horrible for them and very expensive for their family and friends and society. If you could just have a cheap program, which any optician just shine a thing, or even an app on your phone, just shine it in your eye, and it does an approximate thing, and then says, now you really should go see a doctor at this point. This is super useful. What's the value of that app then at that point? So we have this data from patients who are NHS, that's us, probably, hopefully, and it's been labeled, it's been marked by experts who've spent decades training as eye surgeons, and they're literally the top place. Well, I had a massive eye operation. There were 5 people in the room, and the surgeon operating on me using microscopes and micro manipulators and all kinds of tech. He said, is it okay to have these 5 people observe? And I was like, yeah, what's happening? He said, we're training people from New Zealand and America and Canada, and they're paying $5,000 each, so your operation is making money. It's not costing the NHS a penny. And I was like, yes, go for it, right? So this is cool. But now we can train programs, and those programs can be given out on the retina scan, not the operation yet. That's robots. I'm not talking about that. Anyway, so what's the value of that? The value is the value of your data. Now, the more people you have data from, the higher the value. It's not, you don't add it up. It's not like this pint costs, half of 2 pints. There's a massive increase in value having more patient data because you have more cases covered. The NHS has everyone, 70 million people's data from cradle to grave, right? This is incredible. And we have a high genetic diversity in the UK, so it covers a lot of interesting problems. So this is super valuable. So we really shouldn't give it away to anyone. But we could sell the apps that we train on the data. So this is another really important thing. And this is not privatizing the NHS. It's making it cheaper. Like my operation, it's like automating that. And we sell this to anyone else who wants it. And of course, they could be doing the same thing. And it could be mutually beneficial. We could say, oh, we're going to swap apps. You've got one that's really good at oncology care and whatever. And we've got one that's on eyes. And we could trade that. So that would just be a bit like pharmaceutical trade. Now you get into a whole bunch of interesting, if you're into property, how long should the ownership of that trained program last? That's super interesting. I'm not an expert. No, you'd have to come up with some novel way of applying intellectual property law to, what's the ownership model? It's now split across the NHS, the patients, and maybe the company, if there's a company involved, have a little bit of a share in the software, because to be honest, writing deep learning software is pretty easy. It's not a big deal. There's free software out there in large amounts. It's quite good. You can download TensorFlow from Google, which is extremely good and free. So you could use that. So you don't have to. You need a few experts, a few programmers. Like you have to have lots of eye surgeons. Okay, so what's the contrast with all of that? What happens with this public cloud? You put things in a public cloud. Well, there are 2 bits of public cloud. There's a public cloud which runs services. So most of you will use some kind of cloud-based email system like Gmail and search, and you might use a service like a social media platform like Instagram or Twitter or Facebook, God forbid, but if you must, or even worse, WeChat, actually, if you want to give away everything about everything you do in China. So main app is very cool. It does everything. You can order a taxi, pay for your beer, and chat to people while you're doing it. It's like, it's very neat. But these are all based on a business model which actually was discovered accidentally by Google. Google built search, and there were previous search engines. You may remember Alta Vista, but it was pretty good actually. It had 300 million users, and Google came along and did slightly better. Then they discovered this really neat trick, which was click-through advertising. And if they look at the ranking of search results and they put ads against them, and if people clicked on them, they go, you clicked on that because of this. And then we can sell that information back to people, and we can charge them for the ad, and we've got market research and charging for advertising. This is like, what used to happen in TV and Nielsen used to do by phoning up people. What are you watching at the moment? We'll pay you $5. You tell us what you're watching, 1 hour a week. This is now automated. It makes a huge amount of money. It makes as much money as movies and newsprint advertising, all those different channels used to make. But it has really low margins. It's free. It's just using data center resources that you have for doing search anyway. Almost free. It's like tiny microcents that deliver targeted ads to people and count the clicks. So Google are making a mint, as we know. And Facebook and Twitter, all these folks are predicated on this two-sided market, it's called, right? So now they built all these data centers, and they're not busy all the time because 2/3 of the day, half the population are asleep. Or they're in the pub. So there's all this resource. What would you do with it? You've spent this thing on your million-core data center. I know, we could let other people run stuff on it as well. That would be cool, wouldn't it? And we could charge them money. We can have a new business model, which is somebody's trying to sell tickets for Glastonbury. We'll charge them a huge amount of money for an incredibly bad ticketing service. Sorry. Anyone try buying tickets for Glastonbury knows what I'm talking about. But there are other things that are run on the cloud that work really, really well. And the more you pay, the more you get. So as one customer comes along, you run a little container that does some stuff. 100 customers, 1 million customers, you can scale up super fast. And if your business model is you get money from each person, and the scale up costs you sublinear cost, this is, so you double the number of users, it only costs you 25% more. This is really good for everyone. Okay, so the people running the data centers are making more and more money. People running new businesses there. What's the problem with all this? The problem is, once you start investing in this stuff that looks at what people are doing, if you're a business, you're not the Financial Conduct Authority, which is a government regulator. You're not the NHS, which is a state-run, and it doesn't matter how it's run. It's just not, not for profit. And you're not, the government security service or the police, actually, who also do data on people and crime and stuff. If you're not any of those, you're for profit. Your shareholders require you to maximize your profit. That's not an option, right? Unless you structure, that's my way I mentioned matrix.org. It doesn't have to be matrix. There are other companies that do this. Unless you structure the company very carefully, you can say, like Google said, we're not evil, but at some point the shareholder meeting will say, I'm sorry, yeah, all very good hippie Californian nonsense. I'm afraid you have to make more money like those guys are doing, right? And you get mission creep. And so you start to say, what else could we do with the data? Oh, we could advertise them. We could do third-party ads. We could do analytics on more things. We could do more and more deep dives on people's data. Oh, look, we could do all kinds of clever things with smart homes. We could look at your central heating and figure out, when you turn the heating on and off. And then we could look at what you buy, because you buy stuff online. And we could correlate those and say, oh, look, you buy, in this time of year, you put your heating to this level and you buy these kinds of antiperspirants, and maybe you want to buy these ones. We can create more better targeted ads, right? So that's kind of an example, just off the top of my head, of mission creep. So this thing is kind of an issue. And what could you do about if you put systems around that model? Now, crucially, I want to say not all cloud services are like that, because a lot of cloud services are a straight honest business. I'm not saying those guys are dishonest, but they're not a two-sided market where there's a hidden piece of the equation. You're the product for Zuckerberg, right? If you're using Netflix, or you're using the premium Spotify or YouTube's news service, you subscribe and you give them some money and they give you a service, and that's it. It's like using Tesco's. Now, Tesco's have a club card, Boots, a Vantage card. These people have the same trick, but they're not incented to give that data. That's their secret source. That's not a thing they're going to give to other people. That's absolutely, totally not what they're going to do. So there's an interesting thing of the intersection of privacy and the business model, where I'm trying to get to. So, state might be incented without law and stuff, but usually it's not. It's mostly reasonable. The healthcare looking at your data, they're motivated to do better healthcare, right? And maybe cut the cost and do better. It's good. A financial regulator wants to make the world not collapse in a heap again, and so on. The police actually mostly want to sort out crimes. But somebody's got this profit motive, has got to make a profit. But if their business model is you serve better video better, then it's very clear. The trust relationship is incentive aligned with the money, right? So that's the kind of game theory way of putting that kind of stuff. So, could you run healthcare, financial, all those other things on a public cloud? So, what you could. So imagine some clever person inside the NHS or the Financial Conduct Regulator or GCHQ says, we could save a lot of money by paying for cloud. So we could pay for Azure and whatever. And the issue is what could go wrong if you did that, because that's not going to be selling the who committed a crime on this street in exchange for targeted ads to people for better better burglar alarms. Well, it might actually. I could imagine somebody doing that. That would be rather worrying. But that's not quite the kind of primary business model there. What's the issue? Well, the real issue is that the public cloud runs lots and lots of services run by different people in the same computing substrate. So those data centers are what we call multi-tenant. There are lots of people there, and lots of organizations there. And there's nothing to stop that. Some of those organizations could be bad guys. Okay, they can just run stuff. They can pay money to run a cloud thing that scans everything else to see if there are any software vulnerabilities. If you're in the NHS or you're in a FCA or whatever, you could have a super good local team who just know what everything is running because they know what the primary business of everyone there is. But if you're in this business of running many things, there's just a lot going on. It's a bit like, your security in a very small village where everyone knows everyone is quite good. People leave doors unlocked. You go to the city, everything gets, hairy instantly because you just don't know where everything is. And somebody could do something bad and disappear, and you don't know where they've gone. And you're actually tracking them, all those things is difficult. And in the internet, it's super difficult. So sort of public cloud is tricky. So could you turn a public cloud into lots of little private clouds that were a bit like the data centers the health service have? And the answer is kind of, but we haven't got it right yet. So there's a bunch of technology which we're working on in the Turing and lots of other people are working on, which allows you to create things called secure enclaves. You may have heard of a case with the FBI and Apple when some definitely terrorists did some bad stuff in California, and they found their work iPhones, and the FBI wanted to break into the iPhones, and Apple were like, oh, you can't do that because we actually can't do that. And the reason we can't do that is everything's secure on the iPhone, and the backups on the cloud, on the Apple iCloud, are actually secure, and we don't have the keys. That's a part of a technology. There's a whole bunch of different pieces of technology for doing that. Now, this is an interesting pinch point here, because if we start to do lots of stuff with really good isolation of these security properties in public cloud, while we might be able to stop the bad guys stealing your healthcare or financial data or whatever, the bad guys might do other bad stuff and not be catchable. So this is the big moral dilemma. When you build a system that does this really secure isolation, you potentially enable things. And this also is done other ways. The simplest way you can provide a platform for bad guys is to provide a really anonymous platform, like the internet, and not reveal where people are or who they are. And then you could build a system like Tor, which even hides, really hides where you are. And then you could build a system like a cryptocurrency, which allows them to pay with money that's untraceable, electronic version of cash. And then you end up with things like Silk Road and all kinds of bad stuff, like people actually renting out assassins. So actually, providing secure isolation in a public cloud in Azure, or actually Microsoft have a thing called confidential cloud, or AWS, which has a similar thing, Google Cloud have a similar thing. That's not, it's too late. The bad guys already have these bad guy tools. So you might as well protect our stuff and allow people that want to do lots of data science, processing of lots of data, make that processing cheaper and more efficient, take advantage of the amortization of the costs of running all these big data centers for processing that you get from the big data centers. You even get energy efficiency. You actually green them because you can run them near hydroelectric sources, or literally air cool them with convection rather than having AC and so on. So there are plus points about doing that, and the minus points are like, well, actually, there are minus things already out there. I mean, that's not a great argument. So if somebody wants to have a discussion about that, we can go into more detail about that. Adding bad tools with bad people to potentially use is not a good thing. But if most of what you're doing is good, i.e. protecting people's private data, and this is not funny private data, it's not just healthcare. I mean, if you reveal your healthcare data and then you decide to move to America, then you'll find a hard time getting a decent health insurance price. That's one argument about not revealing it. But there are much better arguments about, you're doing a trade with another company, you're doing an acquisition, and it's actually required you keep this private. It's like, it's not optional. It's like, the negotiations have got to be secret. Or you're just having a discussion with somebody who's expressing views you really disapprove of, but you don't want to embarrass them by telling everyone in the world. That's just not a thing. I know that's what Twitter does, but it might be your kid, and then 10 years later they go, you were right about that. That right-wing view I was espousing back then was nonsense, or left-wing, whatever you want. And so people have there are reasons why you need to retain this privacy, which are mostly good. And I would claim, sort of chilling effect on social behavior is much worse. You shift society to all kinds of bad places. There are lots of other problems we need to sort out before that. Okay, I was just going to give a few simple examples, though, about legal requirements. Actually, there's just some things that came up when I was thinking about this talk. One of the things is, before you keep any data, let's say you're setting up a service for selling tickets, what do you need to know about somebody? Well, the example I use is a pub-based one. And my kids are actually, although they're 21, 25, and 30, they get carded, right? They get ID'd all the time. Lucky them, I say. And I was terrified for a long time. I wasn't terrified, but I was just worried because they're carrying passports around. And a passport is a very high-value document. You nick one and you can sell it down the road, Chancery Lane. Somebody buy it off you, for 50 quid. No, I mean, you know what I mean. But it's completely overkill. What you want to do is data minimization. So when you think about anything, why are you keeping all that data? What a load of nonsense. So, what do Netflix need to know about you? They just know you've got a Netflix account and you like these programs, or you watch them to the end, or you watch them 3 times. They don't need to know much else about you. So what does a bar need to know about you? They need to know you are over 18. They don't need to know your age, your name, whatever. If you could have a service that did data minimization, that did what's called disaggregated ID, this would be a really nice system because it would let you do all kinds of other things. It would be a sort of bootstrap for lots of things. Another example of people think, and we could do that. There are prototypes. Canada actually shipped a system. I forgot what it's called, but they've just this year shipped a system that's being prototyped, which does this. You can verify one aspect of you without giving away all the others. It's very nice. So it's an existence proof you can do this. Other side of the coin, you might think it's okay to have a smart front door camera, so you can open the door to the Amazon delivery person. If that camera points at the street, you've just broken the law in Europe. Some people are nodding, so you know this. And in fact, the ICO just wrote very good. The UK Information Commission Office is very, very good. They have really nice little, very readable explanations of what you can and can't do. It's actually, for God's sake, don't read GDPR, but they're nice, one-pagers just tell you what's okay. And so you're not allowed to just film everyone in public. That's not a thing, right? But why do you need to anyway? Why on earth is Amazon doing that? The Amazon delivery person's got a delivery code. They've got a tracker. What on earth? You've got GPS. They can just say, it's me, here's my tracker code, open the door for me. Why do you need a picture of them? What a load of gibberish. So these things are sort of massive overreach. Okay, you could do face recognition and let people in automatically. Yeah, sure, you could do that. Or, their phone is on them and it could do 2-factor with the door and just let them in. So again, it's data minimization is the lesson. Just don't keep stuff if you don't need to, and don't keep it longer than you need to. When you're learning about possible fraud or medical patterns, once you've learned the pattern and the patients are dead, why have you got their data? You need the statistics and the model. You don't need the individual data. They might want it, their kids might want it. I suppose they don't want it if they're dead. But you might, they might want it in sort of their diaries or something. But it's none of your business anymore at that point once you've integrated it in this kind of model. So was there another thing I had? One other example. Okay, yeah, so no, this is not an example, it's just a general lesson. So at the moment, we have a weird thing going on in the world. There are many weird things going on in the world, but one of my favorite weird things the last 2 days is Trump has decided he's not going to let Google send software updates to Huawei. And he's also just persuaded ARM that they're not allowed to sell chips to Huawei because the Chinese are stealing American intellectual property. This is very weird because Android is actually written by Google in London and it's based on Linux, which is a Finnish open source project, and the ARM processors built by people in Cambridge. So neither of the things are American technology. But anyway, so they're actually European technologies, big success stories. Actually, ARM is owned by the Japanese now, and they bought it for a lot of money and jolly good. And so, this is like not. Anyway, but there are 3 reasons behind this, right? One is trade war. It's just standard stuff. It's like firing, blah, blah, blah. 2 is the threat that, there may be intellectual property theft going on, which is a worry. But 3 is there are genuine worries about some companies' privacy. So it's kind of a point in my talk. So if you get a smartphone, an Android phone, I have a paper here actually all about this if you're interested. One of my students now works at Berkeley, has done an analysis of all versions of Android. And this is not just Huawei, this is every Android phone if you have a Motorola or you have a Samsung or you have a HTC or whatever you have. And they all send data to somewhere, all of them, every single one of them. And if you've got some smart widget in the phone that does some machine learning super fast, it sends even more data. And if you turn on, the equivalent, the Android equivalent of Siri, it sends even more data. And where does it send it to? It sends it to where that company gets its data. So Huawei phones, yeah, sure, they've got this privacy invasive thing that they send the training data on faces and voice back to Huawei in Shenzhen, rather than Google in Sunnyvale or in London. And it's like, yeah, okay, so let's have a level playing field about privacy. There's a separate thing, if you're super into this, which is to do with software, not in phones, but in the other side of the equation, inside the network, where the National Center for Cybersecurity, you write a report every year on what they worry about in software from different companies. And Huawei's software doesn't look very good. That's more worrying, because today, if you're looking after communication, which includes healthcare data from your Fitbit or your walking steps or your auto defibrillator heartbeat monitor, all those pieces, you really, really care about that. So, so I should wrap up there because I'm probably over time, aren't I?
That's good.
Okay, but that's it. That's it from me. If you're interested in reading more, my students' paper's really scary. Okay.
Thank you. We don't run away. But thank you for a really excellent talk. I'd like to open up the floor for some questions first. So, yeah.
He's sort of talking about the public cloud being not secure for sensitive types of data like financial information. If we talk about public cloud as being, in this case, things like AWS, so virtual computing, or Google Cloud, or Azure, their virtual computing platforms, for something like health data, it feels like, well, any data really, there's sort of two types of risks. You've got the technical hackers can break into it type of risk, and you've also got the, let's say legal risk, which is whatever company has, owns that thing, either says they will or won't use that data, right? Their T's and C's says,
yeah,
we won't look at your data, or we will look at your data and sell advertising. So in those two models, you're sort of, asserting that the public cloud is not good enough. Compared to, say, the NHS building their own data center,
yeah,
given those two types of risk, you could argue that Google's better at doing the technical stuff than four blokes in a shed in Nottingham building an
well,
center, but they might be more trustworthy and not looking at data. So just be interested in my thoughts.
No, that's a very good point. The only thing I'd say is that the budget for a data center that Google will build is 1% of one hospital. And so actually the NHS has pretty damn good people when they build it. It's not full shed. Plus, most of the software in data centers is, most not all, significant fraction of what you run is open source available. And so you can replicate that. It is true that somebody who works in NHS Scotland running secure data centers is probably paid about 4 times less than somebody doing that at Google, but they might like living in Edinburgh rather than Sunnyvale, for example.
Sorry,
but I know it's a. Yeah, no. I think what you're saying is a fair point, that actually it's not as clear cut as I was saying. You're absolutely right, and that it's quite likely that you could have vulnerabilities in a privately run data center, but there's no reason to allow lots of external people to get into it. So you can have closed networks, you can have auditing. I mean, they do actually. I mean, when we did stuff with the Turing at NHS, it was pretty impressive, the level. Now, it's true, cloud providers vary enormously in how good they are at that. And so one of my colleagues in Cambridge, Ross Anderson, is one of the world leading experts in security engineering software. He actually spent a few months at Google, and he was originally, he went there saying these guys are terrible, and he came back saying they're actually pretty good. But it's a high variability, and so and you may get what you pay for. So. But yeah, it's a fair point, and I think the main thing is just that when you have a public cloud for running multiple tenants, there's this risk between them all. Inside a private data center, you might have multiple tenants. You might, if you weren't good at security design, you could imagine university runs its exam system on the same systems it sends out its course notes, and then I guarantee within minutes our students would have all the exam questions.
Yeah.
So
I don't think there's ever been a single case of anyone breaching a tenancy between Google Cloud or Azure. It never happened.
Yeah. But scanning for vulnerabilities on public cloud happens. We used to get, when we were first doing the Zen hypervisor, we used to get actually an alert from CERT at least one a week, and this required rebooting every virtual machine in the cloud and the whole world that we're running on Zen, because the hypervisor, if it's got a vulnerability, can read everything for us everywhere. So what we work on now is, if you're interested, is SGX and using trust zone on ARM processors, and AMD have a slightly different model. It gives you, and it slightly improves it, but there are still vulnerabilities. So it's kind of, but it's a completely fair point. It's a good question. Yeah.
Any other questions? If anybody's writing questions on post-its, if you just want to hold them up. Any other questions?
Following on from that, so like thinking something like, let's say imagine you're a startup tech finance company or something like that, you're the next Monzo Bank or something like that. Kind of, if you're saying like, I don't really trust Google Cloud, like if you were consulting to them, I'm kind of interested, this is what I do. So it's super, not banks, but like a super interesting, contentious topic, I think. So you would say like, public cloud's a bit scary, but actually having 2 servers in our basement is scary too. Like how do you, they don't have the resource in the NHS, let's say, kind of the other end of the scale.
Yeah, so it depends what stage you are, but basically you can pay a little bit more into a public cloud and effectively rent specific cores. And this is standard across all the bigger cloud services. So you can just say, I only want to run these. I don't want to have anyone else running them. I want exclusive access, and I want VPNs up to the blah. And you pay a bit more because you're not doing elastic sharing, so that changes the economics of the resource sharing. But if you have enough demand, it adds up. So it makes sense. So it's a bit like kind of chartering a plane rather than whatever. So if you were, if you start up with 3 machines in a basement, and you might move to that when you're at 50 or 500 or something. If it depends what the demand on your system looks like. If it's a continuous demand, people using resource all the time, that will be fine. If you have very time varying demand, if you think of like the roads, right? The 4 o'clock in the morning, London's pretty much idle, and then half of the day it's totally wedged. So you need to think about what the model of the demand on the system is that you're serving. And do you need a bus lane for you, which might cost you a bit more because you have to displace all that other. But yeah, it's another good question.
Oh yes, we have 2 questions. Okay, should we go with you first? Yeah, do you want to go first?
Yeah, cool. I like your point about data minimization. It's kind of really annoying at the moment. Whenever you try to sign up for anything online, they will ask you your entire life history. And as you say, that they don't need to know it. They need to know that you can pay for this and where to send it, and that's it. How can we stop this? How can we change this conversation?
So actually, the law does help, and so you can actually, of course, it's annoying for the regular public all the time to do this, but there are organizations out there who care about not just privacy, but about the fact there is a cost. Credit card companies, a cost if they lose information. Typically, they will cover it at the moment for you, but if blah, blah, blah. So we were just literally looking at this, at signing on the Wi-Fi here, and how much stuff you have to give up. And he's the next speaker, right? So you can ask him, but we make up stuff. My birthday is different on every single system that I use. And it's great because I get birthday messages from people. I'm like, well, you're obviously not my friend because you didn't know my real. So, but it's a very good point. But I think you can. GDPR does say they should only keep what they need, and they have to have a reason for it. But it's a real bore to have to do subject access requests and challenges and blah blah blah. So unless it's sort of a egregiously high level of annoyingness, and it's not quite annoying enough, and most people don't kind of value privacy enough. Also, you just make up stuff, and it's.
Do you think GDPR will lead to some pushback on this?
Oh, I think so. It's happening. We did a survey, surprisingly, for university research people. We did a survey of lots of companies about what they thought the burden of implementing this was and how much they thought about this from a couple of years ago. It was really impressive how many of them had a plan or had sought advice for a plan and actually said, this is quite simple. We already did data protection, and why would we keep this data? Unless you have one of these kind of creepy mission creep business models, it's like, well, why would you keep more data? It costs you more storage and more processing. It's like, it's kind of, it's just this, there's still this residual model of all the mobile apps that just say you need to do this stuff. And I think eventually that will, maybe not. It's good.
Okay, we'll take a final question from you, and then John, will you be around a bit later in the break to
Yep,
have some more
sure.
if you want? Okay, go ahead.
I was wondering, the data sets that you mentioned are almost all of them projected, sort of transaction data, projected data from the appointments with the providers and financial transactions. Well, in the past, we worked on the behavioral segmentation model for financial well-being, where you could predict the financial well-being or the segment that the person would belong to purely with the subjective characteristics like how do you perceive your financial satisfaction, what are your attitudes towards certain things. So I was wondering, in your experience, things like financial well-being or others, is it more predictive to run it on the objective data? That would be...
I can't answer that. It's a great question. I've seen people working in the last few years on monitoring people's stress levels and emotions while they're using various services. And I think we're gradually getting an idea which might lead to be able to understand that. It's a really interesting question. I mean, I'm a systems person, so I kind of build stuff, and but I'm responsive to the idea where people come along and say, well, can you tell the difference between those objective data and subjective? And we did this 30 years ago. We were measuring video and audio quality on the internet, and there were all kinds of objective measures of signal to noise, and then there were people going, well, I can't do this task. I can't actually interview a person over this video link. What are you telling me? It's got this stuff. No, it isn't. I can't do the job. And so we ended up with that kind of approach with Angela Sass, who's a very cool professor of human-computer interaction and security, actually, and she did a bunch of work in that 3 decades ago. But it would be really nice to redo those things now, and I'm sure there are probably people in Turing doing that, actually, because it's the kind of thing we have people who worry about and think about that. That's great.
I'm thinking that subjective data would be available already if you look at everything that people are sharing on social media.
We did do one study. We did a small study which kind of speaks to that kind of question, but it wasn't exactly what you're saying. They were interested in mis-selling instruments. So when people complained about they were sold a loan, it was the wrong kind of loan. And so the complaint was a sort of subjective measure. And we tried to establish what the objective, could we do a predictor for that? What was it about the documents this person had filled in web pages usually? And you could do pretty well, actually. It turned out most of them were completely unintentional. They were just badly worded or whatever. And you could do that with some natural language processing statistics. But the people had a very quick reaction, this was the wrong thing, And so that just suggests what you're saying is absolutely vital, because it may be there's a really good shortcut to avoid a lot of problems. But it's really interesting. But there's also another thing, which is, if you're looking at health and finance and security and well-being, there's a big picture there, which would be really interesting, because you might be able to reduce all this surveillance society by just having something where people just go, I'm fine, or don't have to say anything. They don't say anything, they're fine by default. Or they do say something, there's some real problem they're covering up, whatever. But you could imagine a different approach which would shift that. But it's a really, we need to program in that.
Okay, that's a very nice last question to end with.
Cool.
Okay, we're going to take a break now, then we're going to do the quiz. So please join me in saying thank you to Jon for really...
Thanks for the question.